Today we're going to be talking about lesson 6.2, which is on parallelograms. Now, we have a couple theorems about parallelograms. First off, theorem 6.3 says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So JM and KL are both congruent, and JK and ML are both congruent, meaning they're the same length. Theorem 6.4 says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle J and angle L are congruent, and so is angle M and angle K. Those are congruent. 6.5 says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, meaning J and K add up to 180. M and L add up to 180, but also J and M and K and L. Pretty interesting. Theorem 6.6 says if a parallelogram has one right angle, then all four of them are right, and that essentially has to go with 6.5, saying that if one of them is a right angle, then the other one has to be, because they have to add up to 180, so on and so forth. Okay, here's a theorem for 6.4. It says if we know that FGHJ is a quadrilateral, actually it's a parallelogram, that's what that symbol is, then prove that F and H are congruent and J and G are congruent. Well, first we know that they're a parallelogram. So by definition of parallelogram, step 2 says that the lines are going to be parallel. Okay, parallelogram is made up of two parallel lines. F and J, J and H and G are all supplementary. So parallel lines cut by transversal obviously form supplementary angles. And so obviously F and H are congruent, and J and G are congruent, and that's by the transitive property that actually says supplements of the same angle are congruent. Same with transitive property as well. Alright, so let's look at this. It says in parallelogram ABCD, over here it looks like a basketball hoop. The measure of angle A is 55, and the measure of AB is 2.5 feet, and BC is 1 foot. So find the measure of each one. Well, DC is right across from AB, so it's got to be congruent to 2.5, so that's going to be 2.5 feet. The measure of angle B, well, if we know that A is 55, B is going to have to add up to 180 with it, so we'd say 55 plus X is equal to 180. Subtract 55, and you'd find out that X is going to equal 125 degrees. And finally, find the measure of angle C. Well, our theorem before says that angle A and angle C are going to be congruent, so angle C is also going to be 55 degrees. Here's a guided practice problem talking about this spring in a wall-mounted mirror. Creates a parallelogram. Answer the questions now. So, diagonals of parallelograms also helps us out a little bit, gives us some information. Theorem 6.7 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Remember, bisect means that they form two sides that are equal, so AP and PC are congruent, so are DP and BP. Those are going to be congruent to each other. Theorem 6.8 says if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So essentially what it's saying is if I have this line DB, cut the parallelogram in half, then triangle ADB is congruent to triangle CBD. Those would be congruent triangles. Alright, so let's use this information for our second example. It says if QRST is a parallelogram, then find the value of the indicated variables. So, first off, it says find the value of x. Well, I see x in the length of QT, and we remember that theorem 6.3 says that those two sides are going to be congruent. So I'm going to set them equal to each other. I'm going to say 5x is equal to 27. Divide both sides by 5, and I find that x is going to be the value 5.4. Now I'm trying to find y, and I see that TP is 2y plus 5, and RP is y plus 4. So those two obviously have to be congruent to each other. So that means that those two values are going to be equal to each other. And I get 2y minus 5 is equal to y plus 4. Simply a moron problem. There's more x's or more y's on the left, so I subtract a y from both sides, and I get y minus 5 is equal to 4. Add 5 to both sides, and I get y is equal to 9. Next, I'm looking for z. Now in z, I have this angle right here, and I don't see another z. Now, we saw in our last theorem, theorem 6.8, that if we have a diagonal, which TR could be that, or so could QS actually. QS cuts it so that I have this triangle right here. And I have this triangle right here. So you'll see that 33 and 3z are going to have to be congruent to each other. So I'd write 3z is equal to 33. Now I can divide both sides by 3, and I find that the value of z is 11. Here's a couple guided practice problems. In letter A, you're looking to find the value of x and y, and then in letter B, you're looking to find the value of z. All right, parallelograms and coordinate geometry. It says determine the coordinates of the intersection of a diagonal of F, G, H, J with vertices F, G, H, and J being those right there. Well, we can look back into theorem 6.7, and it says if a quadrilateral is a parallelogram, then its diagonals bisect each other, meaning that they meet each other in the middle or midpoint. So if I drew this right here, and I'll do a rough sketch, but essentially F would be at the point -2, 4 right there, that's F, and G would be at 3, 5 up here. Okay, then I'd have H at 2, -3 down here, and I'd have J at -3, -4 down here. Okay, so here's my parallelogram. I said kind of a rough sketch, but you'll see that the opposite vertices of each other is F and H, and J and G. And so our midpoint is going to be this point right here, the middle or midpoint of both of them. So I'm going to find the midpoint of F, H, and make sure that it's the same as G, J. Okay? So the midpoint of FH. Well, to find midpoint again, remember we add the x values, and divide by 2, add the y values, and divide by 2. So for ours, it's going to be -2 plus 2 divided by 2, and it's going to be 4 plus -3 divided by 2. I solve those out, and I find out that the midpoint of that is 0, 1/2. Okay? That's the midpoint of FH. Now let's look over at the midpoint of GJ. Again, 3 plus negative 3 over 2, and 5 plus negative 4 over 2. Simplifying it out, I get 0, and I get 1/2. Notice these values right here are the exact same. So the midpoint, or their point of intersection, would be the point 0, 1/2. Here's an example of a problem that you can try on your own now. Finally, we have a proof. It says, given that we have parallelogram ABDG, okay, prove, and we also know that AF and CF are congruent, prove that this angle right here, BDG, is the same as angle C. All right, so we're going to make our proof. Okay, I'll make a 2-column proof. Proof statement. Okay, well, first, we know that parallelogram A, B, D, G. Okay, that's given. So the next thing is that I know that A angle GAB is congruent to angle